Hello friends, welcome back. Today we are going to learn about the numericals based on lowering of vapor pressure. Now this lowering of vapor pressure means they are dependent on solid in liquid part. So always keep in mind that this equation based on the solid in liquid. The solid would be a salt or liquid, as you know, as a solvent. So the formula over here, the relative lowering of vapor pressure is equals to P naught minus Ps upon P naught equals to N2 upon N1 plus N2. As you know that N2 is the moles, am I right? So moles, whenever it comes the moles, that means it is known as an X. So X is the mole fraction. So here X2, so N2 is known as X2. If it will be have N1 upon N1 plus N2, so that means you have written X1. So here you can write N2 upon N1 equal to X2. So here P naught is mentioned as a vapor pressure of pure solvent. PS is known as vapor pressure of the solution. N2 and N1, what makes the difference? N2 is known as number of moles of solute and N1 is known as number of moles of solvent. So solvent, solute and solution. This is based on the solid in liquid. Now what about this equation? This equation based on all the solutions when they are diluted or concentrated. So here the previous equation P naught minus Ps upon P naught equal to N2 upon N1. As we know that N2 is equals to W2 upon M2 and N1 is equals to W1 upon M1. So I just place the value of N2 and M1 where we get the equation W2 into M1 upon W1 into M2. Now there is a difference between M1 and M2. What is it? N1 is the number of moles, correct? W1 is also mass in gram. M1 is molar mass of solvent, whereas N2 and W2 are the number of moles and mass in grams, whereas M2 is the mass of the solute. Now basically you can see that here the colligative property, where this lowering of vapor pressure depend on the colligative property. What is it? That means which obeys the Raoult's law, and Raoult's law indicate that the properties of ideal solution which depends only on the number of particles. That means of the solute dissolve in a definite amount of the solvent and not depend on the nature of the solute. So colligative property mentioned here, they don't depend on the nature of the solute, whether it's an acid or a base. So here you need to keep in mind that whether it's solvent, which is a solute and the solvent. According to this criteria, we'll solve the numericals. You can see the question. Vapor pressure of H2O at 298 Kelvin is 17.51 mm. Lowering of vapor pressure of a sugar solution is 0.0614 mm. Now vapor pressure is given, so we'll apply the lowering of vapor pressure equation. Calculation, you need to calculate relative lowering of vapor pressure of the solution and mole fraction of the water. As you can see that here the vapor pressure of water is denoted by P naught equals to 17.51 mm. Is that clear? Next we have vapor pressure of the sugar solution. So what is it? So lowering of vapor pressure P naught minus Ps is equals to 0.0614. So according to the equation, relative lowering of vapor pressure. See, lowering of vapor pressure, you will write this. If it's relative word, then you will write the whole equation P naught minus Ps upon P naught. Replace the value P naught minus Ps equal to 0.0614 upon 17.51. You get the final answer as a 0.00351. Now moving ahead towards the next. Vapor pressure of the solution. As given, vapor pressure of solution is denoted by Ps. Therefore, from the equation P naught minus Ps is equals to how much? 0.0614. Correct? And P naught is given 17.1151 mm. So replace the value over here. Therefore, P naught minus Ps is equals to 0.0614. So P naught is 17.51 is equal minus Ps equal to 0.0614. So you get the final answer Ps equals to 17.51 minus 0.0614. you can bring it over here. So you get the answer as a 17.4468 mm. So this is how we find the value of the vapor pressure of the solution. Now what about the third portion? It's mole fraction of water. So mole fraction of water is equals to, so formula by Raoult's law again, is equals to P naught minus Ps upon P naught equals to N2 upon N1 plus N2. What is N2 upon N1 plus N2? We can consider as an X2. Therefore X2 is equals to P naught minus Ps upon P naught. So basically what do we get the answer? 0.00351. This is X2. What about the X1? The X1 means mole fraction of water is in X1. So X1 is equals to 1 minus X2. What is 1 minus X2? Given to us 0.00351 equals to 0.99649 is the final answer. This is how we can calculate the relative lowering of vapor pressure of the solution and mole fraction of the water. So this is how we can solve the numerical based on the relative lowering of the vapor pressure. So children, try to do by yourself. This is the question given below. I hope you understand these numericals very well, and we'll meet on next lecture.